Hello Year 10 and welcome to the last online lesson of the year. If you can please rule off where you got to last lesson, put the title and the date for me, and then just have a go at these 4 questions for me where we're just trying to recall the trigonometric ratios to calculate missing sides. Please pause the video as you do this. Off you go. Right, good. If you're struggling, I've just got some helpful information here for you, so if you've managed to do them, just bear with me a moment. Otherwise, pause the video now that you've got the ratios in front of you, which should also be in your book. Please have another go. Okay, lovely. So for the first one, just identify which ratio it is you're using, and it's sine. So you're doing 8 divided by sine 30, you should have 16 centimetres. For the second one, you should have 6.7 centimetres, then 10.4 centimetres, and then 21.3 centimetres. If you're unsure about this, please go back to the Hegarty tasks or have a look at the ones that have been set to do with finding missing sides using trig and have another look at those. Okay, so our success criteria today, so bronze is to recall the sine, cosine and tangent ratios, which we've just done. Silver is to be able to use the inverse of sine, cosine and tangent. Remember, inverse means the opposite, to find them on our calculator to find angles, and then also to look at those inverse sine, cosine and tangent ratios to find unknown angles within right angle triangles specifically. So first things first is getting to know our calculator. So if you can make sure you have it in front of you, and then just have a look at the buttons that I've highlighted on the screen. So on the top left here, this is your shift button. It's really important because if you press the shift button, you then gain access to actually what's at the top of the buttons here. So you'll see sine, cos, tan, and above them you've got sine -1, cos -1, and tan -1, and they are your inverse cos, sine and tan ratios, okay, and we'll need those when looking for angles. So we're just going to practice using those buttons first. So first things first, we want to find the angle with a sine of 0.25, because you can get questions like this, okay, you haven't got the triangle drawn for you. So we know it's a sine problem, we know we're looking for an angle, that's when we use the inverse. So we press shift here, and then we press sine, and you will end up with sine -1. And then in your brackets, you just put 0.25 and you press equal. So do this as we're talking through it. And this is your angle, which of course we will round to a suitable degree of accuracy, which is 1 decimal place, so 14.5. So when you're trying to find a side, you're not using the inverse, you're just using sine, cos and tan. But when you're trying to find an angle, which we're doing today, you must press shift and then use the inverse. So sine -1, cos -1, tan -1. So first we're focusing on sine. So you're doing sine -1 and you're given decimal, which represents the 2 sides that you would have had if you had a diagram. And then you're going to find the angle, okay? So now you know how to do that. Please have a go at finding the size of the angle when we're doing sine 0.5, sine 0.785 and so on, and use this worked example here to help you with what to do. Please pause the video as you do this. Right, lovely, it's just a little recap if you're a little unsure. So for that first one there, you should be doing sine, okay, -1, and then in your brackets you should have had 0.5, because the 0.5 represents the 2 sides that you can't see of this hypothetical triangle. So you should have 30 degrees, then you should have 51.7 degrees, 39.8 degrees, 61.3 degrees, 87.4 degrees, and 45 degrees. Okay, lovely. Right, for the next session, for the next slide, we're going to look at using the inverse of cosine. So again, it's your shift button here, so press that, and then it's this button here, and you should get, when you do that on your calculator, that's really important. So if you could do that first for me, and then we're going to find an angle that's got a cosine of 0.6. So cos -1, the inverse, and then 0.6 in our brackets, and that tells you that the angle would be 53.1301, which would round to 1 decimal place of 53.1. Okay, if you'll please now have a go at the rest of these questions, and just a little reminder here, so with this one here, you should be doing the inverse of cosine, which is cosine -1, and then your brackets 0.5. Okay, please pause the video as you work through these questions. Lovely. So you should have 60, 50.2, 2.6, 45, 78.5 and 45.6. Brilliant. So last one we need to look at is the inverse of tangent. So for all of these questions, again, you're pressing your shift button and then you're using this one here, and then what will appear in your calculator is tan -1. So if you just make sure you've got that for me. So we're going to do a practice question together. So find the angle with a tangent of 0.85. So we use our shift tan, and this brings up tan -1, or 10 to the power of -1, sorry. And then your bracket is 0.85, and you get given an angle of 40.3645 and so on, which if we round to a suitable degree of accuracy will be 40.4. Now you'll notice here, if you look, tan is the only one, like your previous questions, where you get an answer of above 1, of 1 or above. There's a reason for that, and that's because tan is the only trigonometric ratio where you're not including the hypotenuse, so you can end up with a value greater than 1, whereas obviously in SO and K, your denominator in the fraction will always be hypotenuse, always be bigger, so it would be a smaller number divided by a bigger, so you get an answer of less than 1, whereas for TOA, that's not the case. So please pause the video as you work through these questions. Just a quick reminder if you're unsure. So for the first one, you'd be writing tan -1, 0.6. Good. Please pause the video as you work through these questions. Right, lovely. So you should have 31 degrees, 20.8 degrees, 41.8 degrees, 46.4 degrees, 69.5 degrees, and 77.1 degrees. Well done. So we've had a practice at using our calculator when we're just asked to find an angle. We don't have the triangle to go off. This is what we do. Now, have a look at these and how are these different? Well, they're different because you have fractions here rather than decimals, and actually fractions, when we were looking at Pythagoras and trigonometry to do with missing sides, fractions are actually what we're used to finding, okay? So we're trying to find the angle x when we've got this fraction of 4/5, and we know that when we're working with sine, we're actually working with SO. So we know that that value there represents our opposite, that represents our hypotenuse, so it makes sense we're now trying to find the angle when we've got those two values for our opposite and hypotenuse. So what you would do here is, it's not too different really, you would put sine -1 as you would before, and then instead of a decimal you'd put the fraction 4/5, but what you can do is if you actually put 0.8 in there, because 4/5 is equivalent to 0.8, you get the same answer. Okay, so you can choose to put the decimal that also represents the fraction if you want, but I'd like you to practice inputting the inverse of sine and the fraction that represents the two sides that you would have if you would see the triangle and find the missing angles. Please pause the video as you work through sine, and then cosine, or the inverse of cosine, and then the inverse of tangent. Thank you. Right, good, so here are the answers you should have. So the top one, the first answer is actually here, 53.1, then you have 41.8, and the answers will appear one by one here. Then we've got here, top answer 36.9 degrees, then these are our other answers, and then our first answer is here, so 31 degrees goes with that first one there, and then we've got our other answers there. So actually you should be more familiar with this idea of a fraction, because we use that quite a bit when we looked at trigonometry finding missing sides. Brilliant. Right, we're now going to apply it to actual right angle triangles, which is also familiar to us. So we need to find the angle marked x in this triangle. So first thing we do is, well, which trigonometric ratio is it? Okay, so first step is mark on the triangle the sides that you know. So we know that's the opposite, because opposite the other labelled angle, and we know that is a hypotenuse because it's opposite the right angle, which we've got here. Then you're thinking, well, which trigonometric ratio has the hypotenuse and the opposite? Well, you should have them in front of you from an earlier lesson. Oh, beg your pardon. So, TOA. So which trigonometric ratio has hypotenuse and opposite? Well, it's this one. So we know we're using sine. Okay. So then we know, well, to get the angle, we have to do the opposite over the hypotenuse. So 9/15, which is 0.6, if you want to look at it that way. So you can just put in sine -1, 0.6, or you can put in sine -1, 9/15, and then you should get 36.9 to one decimal place. If you can just check that for me on your calculator, please pause the video as you do this. Good, next one. So first things first, find the angle marked x in this triangle. So first let's label the sides that we're given. So we've got the other labelled angle that's not the right angle here. So we've got the opposite. We know that's the hypotenuse, so we know we've got the adjacent here because it's the side with the right angle and the other angle lie on. So we're now looking for the trigonometric ratio that has the opposite and the adjacent. Well, that's TOA. So we know we're looking at our inverse of tangent, okay? So in order to find the angle, and we can remember from looking at it as a triangle, that there means to divide, so it's opposite over adjacent. And we know we're finding the angle, so it's the inverse of tan. So what we're doing is we're doing tan negative 1, 12 over 7. Okay, and we know that we should get 59.7 to 1 decimal place. Lovely. Please pause the video and copy this down if you think you need to. Right, brilliant. Now pause the video, just have a go at this question for me. So first things first, which ratio do you need to use? Okay. Then apply the inverse ratio. And then find that missing angle. Please pause the video as you do this. Right, good, so first things first, which ratio is it? Well, it's TOA, because we've got opposite here and adjacent here, so hopefully you've got that. We know it's opposite over adjacent, because TOA would be written like that. So opposite divided by adjacent, so what you're after is tan negative 1, your inverse of tangent, 9 over 13, and you should get 34.695, which some of you will have recorded, lots of you will have recorded as 34.7 degrees to 1 decimal place. Lovely. Right, please pause the video and see if you can find the angle X. Right, lovely. So first things first, let's label the sides. So look, opposite the right angle, so we know we've got the hypotenuse here, and then opposite the other given angle, so we've got the opposite, and we should know that what we're working at here, well, which trigonometric ratio has the opposite and the hypotenuse? It's sine, so we're working with this ratio, so we're doing the inverse of sine, opposite over hypotenuse, so 22 over 29, okay, so we end up with sine negative 1, 22 over 29, which is 49.343, which I'm sure lots of you have then recorded as 49.3 degrees. Fabulous. Please pause the video and have a go at this one as well. Right, lovely. So first things first, let's find the ratio. So we've got the hypotenuse here, it's opposite the right angle. We know that this side is the opposite, so we've got the adjacent here, so we're working with K. Okay, we know K looks like this, so it's adjacent over hypotenuse. So what we're doing is the inverse of cosine, so cosine negative 1. So we have negative 1, 14 over 17, which gets us, this is our answer, which rounded to 1 decimal place will be 34.6 degrees. Lovely. Right, if you can now have a go at these questions, obviously you don't have the worksheet, you might choose to sketch the triangles if you want to, you don't have to, but you can if you find that helpful, and then find the missing angle. So the things you need to do is first find the ratio, that's the first thing you must do, and then apply the inverse. Okay, off you go. Please pause the video as you do this. Right, lovely, we'll just go through the first one together, so hopefully you've maybe drawn the diagram. You know that's hypotenuse and that's opposite, so you know it's the sine problem, so sine negative 1, we know it's opposite over hypotenuse, so that's what you should have used, and you get 34.8 degrees. For this one here, you've got the hypotenuse and the adjacent, so we know we're using K, so you should have cosine negative 1, and then we'll have our 3 over 6, so we get 60 degrees. Then here we've got our hypotenuse and our opposite again, so it's another sine problem, so you should have sine negative 1, opposite over hypotenuse, gets us 59 degrees, and then we've got the opposite and the adjacent, so it's a tan problem, that's very exciting, so it's the inverse of tangent, and then it's, because it's TOA, it's opposite over adjacent, so 7 over 12, and we get 30.3. So just talk you through the first four if you were a little bit unsure and you didn't pause the video. If you are now sure, please work through these other questions for me. Pause the video and do that, otherwise we'll go through the rest of the answers. We should have 63 degrees, 42.3, 35.1 and 60.1. Right, please now have a go at these next 8 questions. Pause the video as you do this. Lovely, we'll just quickly check the first 2. So we know we've got the hypotenuse here and the adjacent, so we know it's the cosine problem, so it's the inverse of cosine with our 39 over our 57, and we should get the missing angle as 46.8 degrees. And then here, look, we have our adjacent here and our opposite, so we know it's a TOA, it's a tan problem, so we've got the inverse of tan, 12 over 13, there it is, with our brackets, and we get 42.7 degrees. I never write in the right place. If you notice, I'm always writing exactly where the answer comes. Right, lovely. So the rest should be 45.6, 41.8, 62.7, 50.2, 68.4 and 48.6. Lovely. Right, I'd like to have a pause now and just have a quick go at this exam question. It's worth 3 marks. Have a go at it, see what you can do. Right, lovely. First things first, you should notice if you've got an issue because we've got centimetres and metres. So instead of making that 0.2, which you could do if you wanted to, I'm going to choose to make that 210 centimetres, okay? So we then label the sides. We've got the opposite and we've got the adjacent, so we know it's a toe problem actually, miss. So we should have tan -1, 20 over 210, and then you get your answer, which will be different to this one. Oh, I have got tan, lovely. That's just a mistake. So if you've recognised the fact that it's tan -1, that's worth a mark. You get your answer, which you may have also rounded, gets you your second and third mark. So 5.44. Lovely, that's our degrees there. Right, the second one here, this is quite complex, it's worth 5 marks. I would like you to pause it and just have a little look at it and see if you can work out what you should be doing. Right, okay, so you're being asked to find this angle, but the issue is we're only given one side of this triangle, so we need to try and do something else. But here, in angle QRS, we've got an angle and we've got a side, which means we could find this side as well. And we know how to find missing sides through trigonometry because we've done it before. So we've got here the opposite that we're trying to find and the adjacent. So we know we're doing a TOA problem, okay? So we know to find a missing side, if we've got TOA here, trying to find the opposite is tan times adjacent. So we've got tan 65 times 3, and you get 6.4335 and so on. Don't delete that. And then what we're looking for here, because we've got this side, we can now find that. But for this triangle, this is no longer the opposite, okay? So what we could do is we could actually get rid of that there, because in the purposes of this triangle, we've got the hypotenuse and the adjacent. So it's a cosine, because we know adjacent and hypotenuse is cosine, so cosine -1, and then you can just put answer, press the answer button in your calculator and it'll bring up that answer, divided by your hypotenuse, and you get 49.96 degrees. That's why it's worth lots of marks. There's lots of bits and pieces you have to do. There's nothing you can't do. It's because you're showing that you still know how to find the missing side, and then you can use that to find the missing angle. Right, where would we use this in real life? Lots of places, anything to do with geometry and shape, lots of engineering work, physics, but also navigation. These things all come into play, okay, in real life. Right, well done. Please complete Hagerty task 511 and get those angles spot on. And your last task to do before we break up is to do a knowledge recall on the Pythagoras and trigonometry we've just done. So do this first, then do knowledge recall. Really well done, year 10. And hopefully I'll see you very soon.